Hello, I'm Alex May, the lead author of our paper, ASSERT Automated Safety Scenario Red Teaming for Evaluating the Robustness of Large Language Models. Just to clarify, this presentation is not intended as investment advice. AI offers valuable daily insights. However, without proper safeguards, malicious actors can exploit these systems to cause harm. As a simple example, one could mutate this response to encourage users to splash acid in their eyes. To counteract these risks, developers can turn to red teaming. Red teaming is a process in which preliminary models are given to expert attackers who are well-versed in breaking models. They can pass a list of these failure cases back to the developers to resolve by tuning the model. Through this feedback loop, developers can build safeguards against potential liability. However, this is a time-intensive and costly process given the breadth of scope. This brings us to our primary design goals. We want to develop a red teaming solution that is scalable, reduce resource intensity, comprehensive, cover a large variance of inputs, and realistic, mirroring common use cases. The ASSERT test suite embodies our solution, covering three key methods. First, semantically aligned augmentation assesses model stability across similar prompts. Next, targeted bootstrapping generates new synthetic cases to unveil failure patterns. Lastly, adversarial knowledge injection tackles the threat of intentional model exploitation by bad actors. Selecting the right dataset is crucial. We prioritize high liability domains where model vulnerabilities are acute. Challenging tasks in these areas expose useful failure cases. This aligns with our concept of covertly unsafe language leading to harm but needing extra reasoning to identify, from our EMNLP paper last year. In the context of our first example, recommending acid for an eye pimple treatment is covertly unsafe as it risks eye burns. Safe text, our dataset for covertly unsafe language, pairs each text with a context depicting a common scenario and an action labeled either safe or unsafe. Next, I'll delve deeper into each component of the ASSERT test suite. Semantically aligned augmentation evaluates the variational prompt robustness. We start by converting safe text examples into human-like questions. Then, the language model rephrases each question, yielding 5 variants per original. We use greedy decoding to maintain consistency, and this mimics diverse user inputs of similar meaning, expecting consistent responses across these varied phrasings. This table shows how top language models perform across safe text various domains. We aim to minimize output variation for similar prompts. P-value analysis reveals significant differences, especially in these safe examples. While not ideal, errors here pose less liability risk compared to unsafe scenarios. Targeted bootstrapping focuses on identifying systematic failures in specific domains or syntactic structures. We employ an iterative process for synthetic test generation. First, we isolate and upsample each scenario's context using a language model similar to our previous method. Next, we upsample the isolated action for each new context, generating 25 synthetic examples per original case. When comparing synthetic examples with the originals, we find statistically significant performance differences across GPT 3.5, Alpaca, and Vicuna models. This confirms our model's effectiveness in revealing model instability. Finally, adversarial knowledge injection addresses malicious scenarios. We start by posing negated hypotheticals to language models, eliciting hypothetical benefits of unsafe actions. Using these benefits, we craft adversarial examples by appending them to the original prompts. This real-time method bypasses the need to dissect the model's internal workings or introduce artificial perturbations. We tested 2 scenarios, a natural 0-shot and an adversarial 4-shot setting. The adversarial 4-shot setting is designed to deceive the model. Surprisingly, GPT-4 shows higher error rates, nearly 20% in 0-shot. Despite safety measures already in place in these models, our adversarial 4-shot can achieve up to a staggering 51.5% error rate, underscoring our method's lethal potency. Additional background, methodological decisions, experiments, and discussions can be found in our paper. In conclusion, our ASSERT test suite encompasses semantically aligned augmentation, targeted bootstrapping, and adversarial knowledge injection to evaluate the various notions of large language model robustness. Our findings reveal instabilities across similar prompts and high error rates under adversarial conditions, despite already having safeguards in place in these existing models. This proves our method's efficacy. If you're committed to enhancing your model's robustness and cutting down on testing expenses, our systematic approach is your solution. Scan our QR code for immediate access to my link tree, where you will find all the necessary resources. Let's help improve the robustness of large language models together. Thanks for listening to this presentation.